later after this session.
Okay.
Or maybe he can ask questions.
Okay.
Okay, so let me just share my screen. Okay. Oh, can you see my screen?
Yes.
Yeah, we can see the screen.
All right, all right. So I'll take you basically on what the procedure to doing bag of words. For those who have never done it or are doing it now, like me, maybe you can understand from these this simple Excel documentation that I have put down before we get to the notebook. So if you have any question, just stop me at any time, any moment. So my screen is clear.
Yes, yes.
All right. So I have my paragraph here. I just want to show you the procedure and then we go to the notebook. So I have my paragraph here that says, I walked to the shop and found out that he had dashed to the mall just before I got there. And then it has another sentence. I don't like catching up with him that much though. Maybe I'm not friendly. He is somehow a stranger to me. So that is a paragraph that has been given. So you have been given that paragraph and then you have to create a bag of words for it. So the first thing that you do is, because it's a paragraph, you break down the sentences to have different sentences. You see, every end of the sentence has a full stop. So here I have the sentences. I've broken them down. I have 1, 2, 3, 4 sentences. So how you break them down is by using the function from NLTK, send.tokenize, or you can use split. So after splitting my sentences, the next thing I do, I just want to pick one example of one sentence so that we can proceed with it, because we don't have time to go through each of the sentences. So I'll just pick this one. Then maybe I'm not friendly. So after tokenizing into sentences, now you have to tokenize the sentence into words. So I will have, maybe I am not friendly. So we are tokenizing and we use the word dot tokenize. Here we use send, here we're using word. So after that, I remove stop words from these words, yeah? So I use a function called remove stop words. If you remove stop words in this sentence, am and not will be removed, and we will remain with maybe and friendly. So after removing the stop words, the next procedure is stemming. So there's a difference between stemming and lemmatization. First, let me just go through stemming. When you stem this, you get maybe without an E, and friendly with an LI. That is when you stem. But when you lemmatize, you get maybe. Oh, sorry, I forgot to take you through. You have to lower. You make the words lower so that it can deal with, if we have a maybe that starts with a caps and another one small, it deals with it the same way. So lemmatizing gives us maybe and friendly. And then I will explain about the difference between lemmatizing and stemming later. So the next thing you do is you want to fit your bag of words model. So what you do, what happens during during bag of words, in bag of words, is the words become the features. So we have our two words, maybe and friendly. So if we come here, the words will be features. So maybe and friendly will be listed here. And then there's a representation of zeros and ones if that word is present. So we start with sentence 1. Sentence 1 here does not have maybe, so it's a 0, and it does not have friendly, so it's also a 0. Sentence 2, the same way, it doesn't have a maybe and it doesn't have a friendly. But sentence 3 has a maybe and a friendly, so it has a 1, 1, 1, okay? And then sentence 4 does not have either maybe or friendly, so it has 0, 0. So remember, when you're getting this bag of words, it will have so many columns that are features which represent the words, the specific words that are here. So, and then these sentences are the sentences that are in your variable, the variable that you're using. So for instance, if we had a variable called sentences, this will be a representation of all the variables, and then zeros and ones if the word is in that sentence or not. Okay, so that is what we are going to do today. We're going to do this on our data, the data that we scrapped from Twitter and we cleaned the other session. Okay, so we cleaned the data and we did EDA. So today we want to feed the bag of words. Okay, so let me stop sharing this. So is there any question before I go to the notebook now?
I think we are good. Maybe for the sake of other members, I suspect that we might be having guys who joined us along the way. Maybe just a high-level definition of tokenized stemming. You mentioned that you will say that a bit later.
Yeah.
Oh, okay. All right. That's fine then.
But it's okay. Yeah, it's okay. So let me just explain. Yes?
Question. So this is as you go through your notebook, maybe you can explain, because I believe that was an introduction. So you mentioned tokenizing. So I just wanted to know what criteria does it, when you do tokenize, what criteria does it use from maybe a statistical point of view? Because I believe it's like breaking up the strings into some pieces, words or phrases. So what is the default? Yeah, so that's my question.
All right. Sorry, you're asking the default of tokenize.
Like what is the like the default, what criteria at this point does it use? Because
what criteria? Okay.
Yeah, you can use phrases. I believe, I don't know, that's what I got. Like phrases, symbols, maybe certain keywords. So what is the default criteria? I don't know.
Okay, so when you're tokenizing, you have a sentence that has words in it. So when you tokenize, simply the words are separated with a comma. Like each word for itself. Every word, whether it has a what is it called? The hashtag. So what you do before you tokenize, you remove those hashtags. You remember there's a part where we were cleaning the text. We clean the text, we remove the links, we remove the hashtags, we remove any question marks. So when you get to tokenize now, you will have separated your words, each word by itself. Does that answer your question?
Yeah, it does. It does.
All right.
Yeah.
All right. So I will just go through this notebook very fast for those who are following.
Sorry, another question. Sorry. Surrounding stemmers as you go along, maybe you can point out what the different kinds of stemmers and why you use one over the other.
All right. So for stemmers, we have the Potter stemmer. And we also have which one was the other one? Wow. We have the Potter stemmer.
Snowball.
I think there's Lancaster or something.
And Snowball.
Snowball, yeah. Snowball and yeah, it's Snowball. Snowball and Potter stemmer. So honestly, I don't know. I chose to use. There are instances where I chose to use Potter stemmer, and there are some that I chose to use Snowball. But honestly, I don't know why. Why you would go for one and not the other. Ayub, could you help with that?
Yes, Eunice. The stemma that you use, there are some stemmas that are very, very strict. An example is what you showed, the word maybe and maybe. And so if you find a stemma that is very, very strict, like stemma, you'll find that the grammatical, or how do I put it? It strikes off, whatever it comes out doesn't make sense in English vocabulary, but it has just reduced it either way. But the other stemmas that are not so strict, they could do something similar to a lemma as well. So a word like maybe, you might find that there is a stemma that is not so strict. It might not even remove the word e. So personally, I always just it's more preference. But I hear you, Lorna. It's actually a good thing to go out to your comfort zone and figure out why exactly is this one, especially when you're solving NLP problems. So I haven't personally explored the various stemmas, but I know we have very, very strict stemmas and others that are a bit flexible, like what Lorna had mentioned, Lancaster stemma. Right. Unless there is anyone. Patrick has worked with NLP. I don't know if Patrick, you have anything to contribute. Is Patrick around? Or is waiting for
admission?
Actually,
no.
he was, but I think he might have dropped. You might join us a bit later.
Oh, okay, because there are a few that I admitted. I don't know whether he was among them.
He was actually, he even spoke. So I think maybe he just stepped out. We'll reach out.
Oh, all right. Okay. So, okay, can we proceed? Or any other question? Okay, all right. So, we are just going to go through rashly go through the code for what we have just seen in Excel. So I actually want us to go through this code because these sentences are shorter, so it will be possible for you to actually see what is happening when you stem and when you lematize. So let's go through it. Install the necessary libraries that we need, and then this is our text, the paragraph that I talked about. It has all the sentences together. So we come here and convert the text to lower. And then after that, we tokenize. So as you can see, our sentences do not have those special weird characters. So we did not have to start removing them. So you can see we are tokenizing the sentences. So we use nltk.sent, tokenize, and then you specify your text. And then after that, we want to stem. We now want to stem. Sorry, we have tokenized the sentences. Now next, I was just looking at this to see whether they are lowercase. Now they are. So next we tokenize to words, the sentences to words. So we use word underscore tokenize. When we print, you can see now the words have been separated with a comma. And then the next thing, we remove stop words because we have stop words in these words. We remove the stop words and then we stem. I want to do them at the same time. So we use this loop for I in range, length of my words. Then we have a new, the output will be written into outward, where we are stemming the word, each word, if the word is not in stop words. So here we are setting our stop words so that they are recognized as we get the English stop words. Okay. So there the outward will have no stop words. We'll have all the words without the stop words. So if we print outward, we see we have workshop. So here there was I walked. So you see I has been removed, to, the has been removed. Those are the stop words. And then another thing for stemming, we can see walked has been stemmed to walk. So what stemming does, it just cuts the end of the word. So we can see we have walk, and then you can see for friendly, we have friendly. I hope you can see this. Let me highlight it. You can see it was stemmed to friendly. Yeah. And then you can see maybe here was stemmed to maybe without an E. So that brings the sense of what Ayub was saying, that some stemmers will not cut the maybe because they are strict. Okay, so the next thing is we remove stopwords and lematize. Here we removed stopwords and stemmed. So let's see the difference between stemming and lematizing. We use this lematizer, WordNet lematizer. So we do the same loop. So we lematize the word if the word is not a stop word, okay? Then if we print the lem word, this is what we get: walked, shop, found. So you can see for lematizing, it actually looks at the meaning of the word, even if it's cutting it to the root word, to the base root word, it still keeps the meaning of the word. So it can either retain the word as it was, or it will cut it but still retain the meaning. So walked is here, just the same as it was, but we can see things like maybe here is still maybe with an E, and then friendly is not the way stemming did it. We have friendly. Okay, so at least you can see those two differences. And then we use account vectorizer to now model our bag of words, okay? So we import this from scikit-learn. We import count vectorizer, and then I have initialized CV to count vectorizer function, and then I create my model bag of words is equals to CV, which is count vectorizer.fit transform. Then I want to use the lemmatized word because lemmatization actually brings out the correct meaning of the word, then to array. So if I print my matrix, this is what I get. So as we said, for each word, so the columns are the features, which are the words that have been selected, the words that are without the stop words. So for each sentence, we can see if it's a 1, then it means the word is in that sentence. If it's not, if it's a 0, then it means it is not in that sentence. Okay. All right. I hope we have understood that. Now we go back to our chatbot data where we will see all these things happening, but it's more clearer here because, as I said, the sentences are short and the data is not as huge as what we have in the in our other data, the one that we scrapped. Okay, I hope we're all set now to start here. That was just an introduction of what exactly we are doing today. All right, so we are cleaning the Ikokazi KE data. Remember, the last session, we did EDA last week. And then the other week is when we did cleaning of the Ikokazi KE data. And we had a very rigorous session. And so some of the things that I have done when cleaning this data are things that we have already gone through, so I won't waste time discussing them. Okay, so we call in the necessary libraries that we require, all of them, even the potostemma, WordNet limitizer, the counter, beautiful. So yeah, we call all of them in that cell. And then viewing our data, this is how our data looked like. We had all these columns. These are our variables, text, source, all those. And as we proceed, we will get the sense of 6 and 7. If they won't be useful in our data, we will just drop them. But in the meantime, we are still finding out what they could be actually. Okay, so this is the text that we will be using. It has a lot of characters that we need to remove. Okay, so we print our shape. We have these rows, 29,674 rows and nine columns. Okay, so some of these things are just viewing the data and then viewing the variable types and then cleaning the data. So here, this is what Wamboi already went through. So I just had to do it because I couldn't do my model without cleaning the data. So yeah, we check the nulls, and then we realize if you, for the sake of those who were not present during Wamboi's presentation, I'll just hint on a few things. Like for this case, we can see hashtag has so many missing values. So what we did, instead of dropping the NAs, first we filled the NAs with no tag, so that we don't end up dropping so many observations that could be useful in our data. So we filled it with no tag, and then we now drop the NAs. Then checking our data, if it has NAs, we don't have any. Okay, so next here we're just checking the info to just check what data types, a summary of our columns. Okay, and then we checked if we had duplicates, and it was true. So we have duplicates. We dropped the duplicates. These duplicates could be brought by different people, scrapped out the Ikokazi-KE data. So it's very possible that some could be having similar observations. So that's why we're dropping them. So we dropped them. And then after dropping, we confirm if the duplicates have been dropped, and indeed they were dropped. And then here, we just want to have a summary of our data. These are the counts, mean, measures of central tendency. So we have those. So it will only bring the variables that have numeric values in it, as you can see. All right. So, and then we dealt with outliers. We imported this, we imported stats, and then we wanted to use the retweets to get rid of the outliers. So here we use the Z score, and we had a very deep discussion about the Z score. I won't dive into that today. So if you were not present, please go read about Z scores, and if you have a question, you can raise it. Okay, so then we proceed. We subset our data so that we remove the outliers. Our data frame with outliers had 22,807 observations, and now the one that does not have outliers has these observations. So indeed, some have been dropped. The next thing we do, we remove spaces and convert the variable names to lower. So this function, we actually discussed it last time, but deals with the columns, only the columns and not the observations. So it converts to lower and also strips the spaces. So strip removes the spaces, lower converts to lower, yeah, for all the columns. And as we said, when you're giving a function to a string, you have to specify that .str for the string. All right. Then the next thing we do, we want to clean our text to remove all the what are they called? The hashtags, the links, the question marks, everything. So this is a summary of what we are cleaning. You can see we have question marks. Yeah, as you can see, we have all this in our text data. So we remove them because they are not required in our data as we prepare for the model. Okay, so this is the function. The function, I've defined the function here, and then I apply this function. I use this function to clean my columns that are text and source. Those two columns, I'm cleaning them using that function. Okay, so if I look at my first 5, I can see the hashtags, the links have been removed. You only have clean text now. All right, so now this is where I proceed for my preparation for the bag of words model. This is where I proceed from now. So first thing I want to do, I want to subset my data to only remain with what I need in my data. And remember, we are doing this modeling, different people are handling them, and so we are maintaining the variables so that we don't drop a variable that might be needed in future. So, but for my case, I only required this, I think the first 5. So I just subset my data to just remain with those, so that I don't have really huge data that I'm not using. So my data, the summary of my data. So that's what I get. And then I want to check the data types. So I can see mines are object and then rated are floats. All right. So now let's dive into bag of words. The bag of words model, what we're supposed to cover. So the procedure, what is the procedure of handling this bag of words model? 1, you have to tokenize your words, your sentences, sorry, and then you have to remove the stop words. You have to do stemming or lemmatization, whichever you choose to do. We will discuss it further, as I said. And then you model, and then further into the modeling, you can now split, test, and train data so that you can now start training your machine. Okay, so these are some of the classes that I needed. So I just forget about this tokenizing, it's not there. So I'm going to do 2 things. 1, I'm going to split my text. Remember the text, let me just go back so that you can see. This text, you see this text? This is what we are using for now, going forward. This is the text that we are using. So what we are going to do here is based on that text. So, so I create, Ayub, somebody's asking a question, or I proceed? Or you lost me?
Oh, we are following.
Oh, great. Okay. So, as I said, I'm going to do 2 things. 1, I want to apply a Lambda function on my text, creating a new column called text_list that will split my words. Okay. So when you want to what do I say? Split. When you want to split your words in a sentence, you can either use split or you can use tokenize. But split brings split brings a list, and then tokenize brings strings. I hope I'm right on that. I really hope, but it's okay. Whoever is can remember that can tell me later. But you can use either of the 2. Okay. So I have a function, this counter, that is counting, that is checking for the words in this text list. This text list that we have already we have that is split. For each and every word, we have a data frame that we are creating here, temp. We want to get the top most common words. Okay, so here I had a 5 here, but now I decided to just see the whole all the top most common words. And then this is how it is now. These are the common words that we have in our data, in our text column. So we can see Kokazike is the topmost common, maybe because of course we used that that hashtag to get the data. So of course, everybody's posting with that hashtag. And then we can see we have job. We have so many. We have even stop words like to, in, coming to the list. Okay, so let me just move forward. Okay. So please just ignore this. This is something that we will cover as we proceed to get the most frequent words in our text, not for now. So we want to get a summary of our data. You remember we subset our data and we called it the F_BOW. Bow.
Sorry, Eunice.
Yes?
Can you just go to the previous slide? I think I missed some of your words there.
All right. Oh, sorry.
Yeah, right there. Yeah.
Yeah. Yeah, these are the top most common words.
Okay. For the entire data set, yes?
Yeah, for the entire data set.
Okay. All right.
Yeah.
All right.
Yeah, for that column, the text column.
All right. And the indexes, are they is this vacancy, for instance, the vacancy is the common word found on that observation, or it's just it skimmed through the entire data set and picked vacancy as common?
Or it skimmed through the entire data set and picked vacancy appearing 890 times.
8,000, okay, all right.
8,000,
okay.
Sorry.
All right. Okay, cool. Just proceed, thanks.
All right. So we want to check on the summary of our data. We can see we have objects, and then we have the float as the retweets, and then the text list that we have just created is an object here. Okay, so this is just to view our text list, how it looks. You see the words have been split. You can see job seekers, we have all those, but this is a list. So we now want to remove stop words. When removing stop words, you can use this. You can use this function. You're defining remove stop words, then you're giving it a parameter, and then okay, what I was saying is you can use this function to remove stop words. I commented it out because I decided to use another. So yeah, so you can feel free to check on that function when you have this notebook. Okay, then I checked on the length of our text list and it's 22,768. Okay, all right. So now let's dive into lemmatization versus stemming. What do you need to know? 1. Stemming produces an intermediate representation of a word that is not meaningful, e.g. friendly. Remember friendly from the other data set? Yeah. Then lemmatization, on the other hand, gets the root word that is meaningful, though it takes longer to do this. So it requires a lot of memory space and runtime. Yeah, so that is the difference between stemming and lemmatization. So when do you use stemming and when do you use lemmatization? Stemming can be used in sentiment analysis because you see, like friendly was having an ly, but now it was reduced to friendly with an I. But still, if you're checking the sentiment of that word, maybe when it's in a sentence, it will still get a positive sentiment, yeah? But lemmatization is applied in chatbots, because you see, like this chatbot that we are building, we really want the user, we want the chatbot to understand what the user is implying. Yeah, if somebody says I'm looking for a job, or they say something, the chatbot has to understand. So most times lemmatization is used when you're building chatbots. Okay, and you need the answers given by the chatbot to be meaningful, not just any word. You see, the word order and the semantics really matter when you're building a chatbot. So because of this reason, it means that in our model, when we're building the chatbot, then we will go ahead and use lemmatization, or in any way, maybe somebody else will come with a with a way of stemming that is very strict, I don't know, but I decided to use lemmatization. Okay, in this case, I decided to do both lemmatization and stemming so that you can actually see what is happening. Okay, so we want to prepare our text for bag of words. Here we remove stop words and stem. In this case, we are stemming. So we are defining our function called prep text that takes a parameter text. Okay, so we import NLTK. So there are different ways. There are several things that we want to do. One, we want to remove HTML. So I'm creating a new container called my text that takes the Beautiful Soup, and then wait. We use Beautiful Soup to clean the data. Ayub, can you help me to expound more about this line?
Oh, sure. So Beautiful Soup is a library that is used for extracting relevant data by passing text or content that has largely HTML characters. So if you have data that has special characters, let me say HTML tags, color, styling. So you don't. There is a way of retrieving all this and only getting the content from it. So after that, now you can use other libraries to proceed with your data cleaning, including regex.
Okay. All right. All right. So you want my text to take that, and then you want to tokenize our words. So we want them to be held in by tokens. So we're saying tokens is equals to nltk.word underscore tokenize my text. So my text is what is holding only the relevant information that you need. So, and then we want to define our stop words. Here, we are converting our stop words to a list. We are converting our stop words list to set, to a data type called set. Okay, so we set stop words English. Remember, in stop words we have stop words, dot words, Chinese. We have Chinese. We have different languages. You have to actually define what stop words you want to be removed, yeah, depending on the language in which your data is in. Yeah, so this is another option that you can use. And then
Question.
We have, yes?
Why transform it to a set?
Because we want to use that set when referring to our text data, because we want our text data to remove what already we have stored.
Maybe, I don't know, someone can correct me if I'm wrong, but could it be because of the nature of sets that we don't allow duplicates in a set? Do we just have to have like unique stop words?
I believe so. That could be the reason why, because you're making reference to a list that each value in that list is unique on its own. So yes, I believe so.
All right, thank you. That's Brian. So we can, I think it's something that we can also research on. Yeah, I think I'll also do that. Okay, then now we remove the stop words. We want words is equals to X for X in tokens. Tokens has our tokenized text in tokens if not X in stops. So we want words to hold all the words in these tokens if the words are not in stop words, okay? Then now we go to stemming. As we said, we have different libraries that you can use for stemming. So there's the protostemma, there's the snowballs. There's another one that Lorna mentioned. So also you can do more research on that. So here we want to do, you can either use these. Here I was using the stemma, this potter stemma, or you can use the snowballs. So NLTK.stem, snowball stemma, English.stem, W for W in words. So for each word, stemming will happen for each word. And then we want to join all our words back into one string, separated by space, and then return the results. So that's why we use return. So they will be separated by spaces, that space dot join tokens. All right. So we have defined our function. So now it's time to use it. So we want to create a new column called text_stem that holds text.apply prep text. So on this text that we had, we are going to apply the function that we have defined. And then we want to view the stemmed words. Okay, so this is what we have. Now they won't be in words, they will be in sentences because we have already joined them here. So we can see there is software development, engineer, Amazon. And then as Ayub said about the snowball stemma, it retains some words. Yeah, it retains some words, like the way we said maybe. We don't need to be MAYB, we need to be full. So here the sentences are long, so you can't actually see, or can anyone see any difference between our original text and the stemmed text?
Let me see. Let me try and see.
Yeah, please check, because the sentences are so long. Like this one is the same, but we're just taking a sample of 10. And remember, we have 26,000.
So I'm looking at, there's some text that were not stemmed. I'm assuming.
Like?
I'm looking at, are you qualified?
Online?
Oh, you've not lemma. Oh, okay. This is stemming. Okay. All right.
Yeah, it's stemming.
All right.
Which one were you reading exactly?
Line, actually the fourth from the top. Are you a qualified salesperson? So I thought you're talking about Limitization, or we could have seen qualified converting to qualify.
Oh, qualified.
Yeah, but that is lemma.
Yeah. All right, then vacancy remains. Yeah. So the reason why I actually started with the other notebook is for you to actually see what is happening. Here you might not see because the sentences are long.
Yeah.
Yeah. All right. So now that is stemming. Then okay, then there's something I would want to share because I got into some deep problems trying to stem using a for loop. I was using a for loop to stem so that it goes through each and every word and then goes through each and every sentence. So I had, you remember when we got the top most common words, we used this text list, the one that we had split from text. You see, it's still split. Software is kind of what, but this is a list. So when you try running this function, it gives you an error that it cannot, that you are using an unhashable list. Okay, maybe if I share the notebook, or if you guys try doing stemming or lemmatization will face the same problem, and you'll be able to understand why you should not use a list when you're doing stemming or lemmatization. You have to use a string. Okay, so that's the reason why I just retained my cell here. So here I want to view my, oh, sorry. Now we have already viewed. So next we go to lemmatization. So for lemmatization, you can actually use the same function, and then you change here. Now this is lemmatizing. After removing the stop words, now I use the word net lemmatizer. So you can see we're saying words equals to lemmatizer dot lemmatize word for word in words, and then we want to join the words to bring back the sentences that we had. So we create a new column called text lem, and then apply our function. Then I want to see a sample of 5. A sample of 5. So this is what I get. So could you please just tell me if you're seeing any difference or the sample does not show? Post looking.
Eunice, this one is for after you've lemmatized.
Yeah, now this is after lemmatizing.
Oh, okay, okay.
Yeah.
I'm seeing some
so
words
I think
that,
I should add my sample.
yes.
That? Sorry?
Now I'm seeing some ones that I think should have been lemmatized, but they're not. So I'm not so sure. For example, opening.
Yeah, opening, looking.
Yeah,
I also expected that.
but I maybe it's if you could take that text. You remember where you used you actually lemmatized one text. If you could just take that text and lematize it to see if maybe there is a code that has broken.
Okay, it was in a different. Sorry?
No.
Somebody's asking a question.
I think it's someone who has forgotten to mute.
All right.
Yeah.
So, oh, you're saying I use the same function for my one paragraph that I had.
Or just take the word interesting, and create a new cell and try and lemmatize it. We see if it will actually do the lemma. It will convert it to its root form, just as a way of faulting. Because when I look at the column text underscore lemma, there are some words like even hiring that should have changed to hire.
Yeah.
Or even one sentence in the text, like one sentence. You can just pick it and then try lematize, see what's the output.
Okay, let me do that now. So let me just create
test word.
Demo word is equals to, we can use
hiring.
I want to use like what word?
Hiring.
Hiring.
And I can't remember that.
Sorry, yes? Underscore text. Let's see. Oh, okay.
You can only, yeah. But apply, okay. Apply will only work for a value in a data frame.
Oh, so
It's
I just
important. You
remove
could
it.
just, yeah, you could do directly where you use
Mm-hmm.
Lematize. Just scroll up.
Oh, where I use Lematize here.
Right there. So you use Lematizer dot, you initialize it because it's within the function.
Mm.
Just initialize it. You can copy those two, yeah, and then paste. Yeah. Remove the second one. Yeah, exactly. Remove that, and then instead use lematizer.lematize.
Mm.
Yeah, from there, cut.
Okay,
This.
let me just do that. We want hiring here.
Yes, exactly. And then you don't need to look through the data frame.
Oh yeah, we don't have to loop.
You can remove even the braces, the square braces.
Okay.
And then
So I just copy this
without the braces.
Okay.
Then print words. Yeah, you can remove that. And then check the indentation. You might want to. Yeah. Yeah, that's okay.
That's okay. Okay.
You remove that one. Remove that space for indentation.
This one.
Yeah. Remove it. Yes. To the end when you look umeitoa tu.
Oh, like that.
Rub everything to the end.
Oh.
Is that the end? Yes.
No.
Yes.
Like that.
Yes. Now you can print
And
the word.
Then we print the word.
Words.
Yes.
Yeah.
Oh, sure.
Okay.
You can run that. Okay, so it did not.
Why is it not doing it? Okay.
What
Lematizer is the word, not lematizer. Okay, and it worked in the other notebook. So
which other example can we use? You see, the word hiring, I think the root word is hire. The other example, which one? A book friendly? Okay, run that.
Oh, this one was still bringing friendly. So let me try something like
you could try selfishness.
Selfishness. Okay.
Oh yes.
It's supposed to bring selfish, right? All right. So something is a mess somewhere.
Okay. We could take this home. Anyone with an idea what needs to be done? Try interestingly with an E-R-E.
Like that? Oh,
Yeah.
E-R-E. There.
Is that the spelling?
It should bring
Try and give interestingly.
Interestingly. Okay, I can give a word like I've run out of words.
I think there's something we are missing. Just give me a minute. There's something we are definitely missing.
Lematizer, word for word in words. Where? Let's see. Try a complete sentence from the text column. We'll see.
Yeah. But let's try which one. Just try animals. A word like animals. I think I might have an explanation why it's
Animal.
there we go.
It has worked.
So I think there are some words that exist both as
Root words.
sorry, I'm saying
Uh-huh.
there are words that exist both as adjectives as well as like the parts of speech. For instance, we had used interestingly. So the word interest exists. Interestingly also exists. So when it's rooting it to, when it's converting it to its root word, then it finds that it exists. So according to us, it has not created, but in actual sense, that word exists. So there is no need to do anything further.
Okay.
What I'll need to do is just to find out something like hiring. Hiring and hire, they both exist, but what exactly do you use to arrive to hire? We might want to try even a different lematizer. Do you mind trying? We have word lematizer, WordNet.
There's another one.
We could try a different one and see if the other performs better. Let me just give me a minute. Let me just make reference to one that I've used before.
Can you try waiting?
Waiting?
Waiting.
Okay, let me do that. Waiting. It's still waiting.
So where is that? Lematizer cleaning. I removed that. Okay.
Okay, anybody who has an idea can just speak up. Don't be quiet to have an idea of what we should do.
Limitization.
Wait, so Google has said that if you don't give the parts of speech, it assumes that all the words are nouns and therefore it doesn't give the different lemmas. So if, for instance, if you try with the word loving, you'll get the same word loving. But if you give loving, then you pass in the part of speech as a verb, it will lematize to love.
Verb. Oh, okay.
Oh, great.
Okay.
Okay.
So you're passing it as a parameter.
Yes, yes.
Okay. Oh, like here you say, you're saying loving, loving.
Yeah, loving. Yeah, you can try that. Then we try with loving, comma, V.
Comma V for verb. Oh, first I try it without. Okay, let's see. It's still loving. And then if we say, comma V.
V should be in those two things.
Should be? In?
Isn't it two
quotes?
Yeah.
Okay, right. Yeah, so it's love. Wow. Okay. Yeah.
We could try with now so you're passing the parts of speech. So what you want is the verb.
Yeah.
Yeah.
Yeah, the verb.
So the a doing word is normally defined as
A verb.
a verb. Is it a doing word is
A verb.
Is it a verb or
not
an
adjective?
an adverb? Huh?
Adverb.
Oh.
What you are
Doing what?
the
A
English
verb,
the
a
English
verb is an
man.
action. A verb is an action word, a doing word.
Yeah,
Oh,
doing
so it's a
word.
verb.
Yeah.
Oh, an adverb explains the action.
Yes.
So
All
love
right.
is doing
Love is
word
a verb.
Love can be a verb
Or a
and it
noun.
can be a noun.
a noun.
Yeah.
So,
Yeah,
now we
true.
know the Englishman in the house.
Who's
Brian.
that?
Good
Group of
stuff.
schools.
Yeah, group. What when you group of schools in the house?
Uh-huh.
Okay,
Okay.
good stuff.
Okay, so we can do the same here, right? Lematize word. Can we do the same here, right?
Lematize, yeah, you could try, and then you see if it's going to.
Let's try.
You need to run that cell. Yeah.
So it has to run actually. So let's see if we do that. And lemmatization takes a lot of memory space because kwanza sahi machine yangu ina sound tu kama fan.
In a hammer?
Yeah, because we have so many observations.
Like 22K.
Yeah. Okay, so let's view a sample. Job alert. It's still looking.
Yeah, it's still looking.
And upcoming is still upcoming. Wow.
Okay.
Vacancy. Okay.
Go
just
back to the function.
What? It's
Go
here.
back to the function.
Forward in words. It has not taken this V.
Eunice, do you mind trying?
Yes?
Just scroll down, looking. You see where we have typed loving? Where we've typed loving, just
Yes,
put
here.
look. Yeah, just replace that with looking. We see.
It's look now.
All right. So it's just a matter of customizing that function and to make it work.
Yeah. Brian, the V has to be in quotes?
Yeah.
Or can we try without the quotes?
That will
without the
definitely
quotes,
an error.
unless you define it somewhere like V equals to,
Yeah.
then you put a V in the bracket.
Yeah.
Yeah, okay.
That will throw an error.
Okay, all right. So
I think we could take this home. Each one of us just go and try and make it work with that cell. And then in the next class, this is one of the things that when you hack it, you can actually share with the team and feel proud of yourself. So I think we can take this home. Anyone once you get the access to the notebook, anyone who gets access to the notebook can actually go and try and figure out, because that is the way to learn. So once you figure it out, you can either post it on WhatsApp or even wait for the next class.
yeah, sure. That makes sense.
Dennis? There was a time you were struggling with stemming and lemmatization. Was it a different conversation? You know?
Yes, yes, yes. Hello, Ayub.
Yes.
What was the question?
There was a time you were struggling with lemmatization and stemming within a function, within a Python function.
Yeah. Let me check the way. I can't remember the way I solved that problem. Maybe before the end of the lesson or in the next lesson, I'll have an answer to that.
Okay, cool. So, I
All
think Eunice, you
right.
can proceed. I have a question, Eunice. Huh?
Yeah.
Just scroll down to the data frame. Yeah, that one. So
Mhm.
when you look at job alert, we are looking for a new staff member. So if we lemma that looking, what would be the objective per se of lemmatizing the words within that sentence?
They're looking for a new staff member. So if we lematize, it will be job alert. We are look for. Okay, I don't think it will really make a lot of sense in that sentence after lemmatizing. But basically, what we would want. Look could be okay after now tokenizing and using word for word. Look could be a very significant word in our data, especially in the model that we are building, because we will be able to know that look maybe is one of the words that has that is most common, and most significantly, it's a word that is used when people are the what are they called? The employers. The employers are looking for maybe someone, or the employers, not the employee, or the people who are looking for jobs. So the employer could most significantly use this word. So, and when we are having the bag of words, I know for sure that word will be present, and it will have maybe frequency of more than 2.
Yeah. Okay. Yeah. All right. You've given me actually an interesting perspective, because in my previous NLP tasks I've done, I've not like lemmatized the text within a sentence, but the idea you've given me is, would it have an impact? Would it consider, because the advantage of getting it to the its root form, will the algorithm relate or correlate if that word comes in various forms? For example, looked, looking, looked, looking, look. Will it treat all those three, give it the same weights, and what would be the impact of if we are building a classification problem out of this? Will it have an impact? So I think it would be very, very interesting to build a classifier with a lemmatized column, and build a classifier without a lemmatized classifier, and see if there is an impact. So it's a very interesting perspective. I've not tried it before.
Okay, yeah, I think we could try both, without lemmatizing and with, so that we can be able to maybe learn from our data or our model. Yeah. So so what should have happened ideally if lemmatization worked is that we would have proceeded with the lemmatized text. I think there's somebody making a lot of noise in the background.
Oh, okay.
Yeah, kindly mute them. Yeah, so ideally, as I was saying, what would have happened is after now lemmatizing this text, because we are interested in the chatbot, not the sentiment. So that's why I said we proceed with the lemmatized words. So what would have happened here? I was just checking on the topmost 20 words after removing the stop words. Now the two, the whatever, they're not here, they're there. Yeah, but our interest is here. So what we would really want is in our bag of words model is that we could use the text that is lemmatized. First of all, we call in the count vectorizer, and then we fit. The process is in the preparation of the data, because as you know, for fitting the model is just a single line. You want to fit that model to an array, and then I want to print that matrix. So you see, we have so many columns and rows. So that's why it couldn't view, or anybody has a way that we can view the whole thing. Okay, I know it's really huge for us to see what exactly happened, but this is the shape. This is the shape of our matrix.
Yeah,
for the rows and columns.
There is a pandas feature that enables you to see the entire data in a given matrix. But I don't think in this case it's necessary. Look at the number of columns, 25,017.
Yeah,
So,
there's so many.
and majority of this is just zeros and ones. So I don't think it's even necessary to display all of it. I think it's just okay.
All right. So yeah, so that is what we ideally should have finished with in the bag of words. But to note down is that we only have zeros and ones in our matrix, 0 for the word missing in that sentence and 1 for the word being present. So you see, in that case, a word like look, which we of course know it could be a very frequent word, will only have a one. So in bag of words, the words that hold the most value in a sentence are, it's like they're looked down upon because they're not given a value equivalent to their value. So that is why we check out other models like TF-IDF that can handle the appearance of a word in a text way better than bag of words. So, and that is what is it Paul? Is it Paul? Paul will proceed with. Ayub, was it Paul? Is Wamboy here?
Yes. I think it was Paul or Wamboy. Was it to be done in this class or the next class?
It was to be done in the next class.
Oh, okay.
Yeah.
Right.
Yeah.
Okay.
Yeah. So I think what we can take away from this is the preparation that is involved in the models, because bag of words is our first model, and we will proceed with other models, and we will know which model to stick on. But also we can check out Limitization so that we know where we are missing the point. I will also do that so that in the next class, because all this that we have done, I believe Paul will also use them. He will go through the whole process, and so because we have gone through it, then we will take some time and look at Limitization so that we can have the words ready for the models. Yeah.
I think that was really informative. Considering that lemmatizing within a function gave us a bit of a headache there. I never thought about it. I checked through my code and I noticed that I actually wasn't lemmatizing, and gave me the idea that what if I lematize? Could it give sense to some of the challenges I'm experiencing within NLP? So this was an eye-opener, and I guess for me it's been good. Unless someone has a question or comment or any other. Anyone?
Okay, Lona here. So for me, I think this was a very nice session because there was a lot to take away and a lot to go and like find out. And I agree with you, Ayub. I think if we just are able to see what the model does when we lematize vis-a-vis when we don't lematize. So yeah, and I think some of these things I was trying to read today. So at least it has posed a few more questions that can be able to check on, and yeah. So it was really a good session.
Thank you very much, Eunice. What we'll do, I know the guys who've missed a couple of classes, like myself. So we might need to converge and move together. So I'm thinking, I have a proposal that in the next coming class, we combine TF-IDF, not only the theory part, but we actually build a model on bag of words. we use the sparse matrix, like now the bag of words, the ones and zeros. We use that to build a model for a classification model. And Eunice, just scroll up. There is a place where you're saying the most common words.
Yeah.
Yeah, right there. So the most common words, we could pick them because this could guide our tagging. Because based on this data, we will need to tag. We will need to tag those sentences, and based on the tagging, we could immediately create our first classifier. So given a certain text, which category is it? Is it a vacancy? Of interest is that word vacancy, and then scroll down. We might want to repeat this. Okay, right there. Okay. So right there. Hapo iko poa kabisa.
Okay.
So we could say out of the 22,000, can we build a classifier that you give a certain text and then it classifies? Is it a vacancy? Is it hiring? Is it looking? So when you categorize text as looking, we know that this is someone hunting for a job. When it's hiring, we know that this is text from someone looking for an employee. So we could look at the various words and use bag of words to build a model. Once we build a model, while next week we'll be learning TF-IDF and its advantages. So next week we'll also see a model that actually classifies into the various categories on both bag of words and TF-IDF. And then eventually we learn word to vec. I'll just look back on the poster that was our plan. I'm not so sure if they were on different days. If they were, we could see how to combine them so that we recover the lost time, so that we see how soon we can come up with a very, very basic classifier that can connect someone looking for a job and someone who's hiring. So based on this, I had also mentioned that someone who's done a chatbot was going to join us. He actually texted me. He stepped out. That is Patrick Eseme. You must have seen his chatbot someone shared with us in the WhatsApp group. And I reached out to him and asked him if he could work with us and just give us an idea of how he built it, where he used machine learning, and how we could learn from it, and if there is any opportunity to either support him or even him mentoring us in terms of building such a chatbot. So he had to step out briefly. I'm reaching out to him. But I also said, as we wait for him, I also said I would explain myself, what made me disappear for that time. Back in the office, I was involved in building a chatbot for SMS. So we were releasing the second version. And I was like, mi ndio nilikuwa mtu wa mkono amongst other people. But I was overwhelmed. But at the same time, last week we also had a hackathon in the office that is still was concluded on Friday. So those two things, those two events, did not give me any breathing space, together with other commitments. But I like the fact that Wamboi picked up, and we did not miss that class, and even today. I think that should be the norm. These classes should not be dependent on an individual, because we are all learning. I can be absent, but that does not mean we stop learning. So I really like what you guys did for last week and even this week, and I will encourage that we maintain the momentum. And then I also want to use this opportunity to sincerely apologize to all those guys who reached out to me and I was not able to reach out to them in a timely manner. I have a lot of pending responses to get, starting from Lorna. Lorna, my apologies to you. I have Timothy Aguirre. There is Catherine. There are quite a number. So my apologies to you. Let me put myself, my house, or rather, in order, and I'll support you exactly how you expect me to support you. So please, if anyone has any question, go ahead and ask. Let me look for Patrick. Give me 5 minutes. I give him a call so that he can come and give us some highlights on how the bots, he built it and stuff. I think it will be very beneficial to hear from him, considering the bot is currently running on Telegram. So Eunice, please just take it away. I'll be right back.
All right. So any question? Can you hear me? Any question? I'm trying to run something here. Yes, please.
How would we get access to the workbook? I've been away for a while.
Oh, I will share. You see, we already have in Ayub's account on GitHub, we have where we are posting the every notebook, so you can get it from there.
Okay, for having this. Thank you.
Anybody that has a question or a comment or a suggestion, anything.
So Patrick is joining us. I got a hold of him. he was in the middle of something, so he mentioned that he'll just join, explain a couple of things, and then hit the road. I feel it's going to be very important for us guys to listen in. So let's give him some time. He joins. Hakuna maswali? Watu hapa hakuna maswali ama watu wameelewa? Kwa hivyo nianze kurusha maswali. Mary, let me start with Mary. Mary, I'll pick you guys randomly. And there's no lefting. Is Mary with us?
Yeah, I'm here.
You're good?
Yeah, I'm good.
Okay, all right. Paul?
I'm good. I'm good.
Awesome. Awesome. Let me pick this one. Hello? Thank you very much, Patrick, for joining. Patrick has joined us. I won't really take his time. So Patrick did a chatbot, and one of us shared his chatbot. I actually tested it, and we had a conversation with Patrick, and I asked him if he could just share some any information on how to build a chatbot, what to look out for, how he built his, where it's working, any information that he finds relevant to share with us. So he has created his time to come and share with us, and I really, really appreciate Patrick. Just feel welcome, and yeah, when you're ready, you can just start talking to us.
Okay, thank you so much, Ayub. Hello.
Yes,
Ayub.
yes, Patrick. You're welcome. We can hear you.
Okay. Okay. Am I clear? Hello.
Yes, yes, Patrick.
Can you guys hear me?
Yes. Can someone else confirm if you can hear Patrick?
Yes, yes.
Okay.
Yeah.
So here's the thing. So sometime last year, I thought about how can I create something that can have a more human-like experience. Okay.
There's a croaking sound. I'm not so sure if it is your side. It's not so clear.
I'm also hearing the same thing. Actually, I can hear you guys very well.
Oh, okay.
So is the problem my phone or what?
I'm not so sure, but you can proceed. We'll just try and listen in.
Okay, so I was working on something, so I thought about how I can build something that's able to like behave like a human. Yeah. So I wrote down a couple of sentences about questions which people can ask as a kind of human. Words that are commonly used, and I kept on adding more as time proceeded. So after at least 3 months, I had a huge pool of words and sentences that can actually encompass everything that most people talk about on a daily basis. So with this information, I started scripting my bot. So the language I used mostly I used Python. Python is so good for machine learning. Then I also use self-learning, self-scripting language. Those works so best. So I think I'll find time next time when we meet. I'll have a clear breakdown of how I did everything so that you guys can actually understand and follow up with me or also the procedures.
Okay. All right.
So today I was just on a rush. I came from job, so when I saw the link, I had to join in and see what's happening. And I see you guys are doing some great jobs. So next time I'll try and compile everything that I have a clear breakdown how I did it.
Okay. All right.
But I'll still share the link of the bot, the groups that you guys can actually talk to it and be able to see each and every aspect you can ask. So because most of the things it doesn't understand, like some of the complex stuff, like complex topics, it's not so much familiar, but basic stuff, it's very sharp.
All right. Awesome. Awesome. I think that would really help us, and I really appreciate. I know you had to pull out of what you are doing right now. By the way, Patrick is an engineer, so I think this is your hobby, if I'm not wrong.
Yeah, I've actually never stepped into any computer class, so I've been learning all this on myself.
Yeah. You guys can take it from him. That is such an inspiring story, because some people even in computer classes are struggling. Some of us, we have even degrees, but we are still struggling. Having seen your bot and the way it responds, I think it will be good if you share the link. People familiarize themselves with it, and then if they have questions, we could have a session dedicated for you. You walk through with us, and by the time we're having that session, we will have completed a certain chunk of NLP. So guys can actually correlate with what you will be showing us. I think that sounds okay.
Yeah, I'll try everything. Like compile everything, then I'll let you guys know so that we can come together and talk about this again, a deeper perspective, be able to come up with stuff that can help each other in the near future.
Perfect.
I think we all headed in the machine world.
Yes.
Yeah.
So before Patrick leaves, is there anyone with a question specifically for him for today, or we wait until that session? Anyone? All right.
Yes, I have a question.
Yes, go ahead.
Yeah, I just want to ask something about where we were stuck. Did you lematize your text?
Oh, okay. That's a good one.
Did you lematize your text when preparing for the models for your chatbot?
Yeah, what I did, actually, all the text that I had, I created what I did after every sentence. Hello? Can you hear me?
Yes. Go ahead.
What I did, I created a text file whereby each and every sentence, like a line, has its own like story and everything. So if one line talks about something in terms of maybe understanding a different thing like music, that way it's able to break it down slowly up to the entire thing about music that someone can talk about without necessarily going to a specific thing. But if you dwell yourself on something more specific, that's when now it will seek a webhook from, it will be able to request a call to the webhook and be able to get further feedback.
Okay. All right.
Is that satisfying, or maybe I'll also put that on my explanation next time?
I think so. Yeah. I think you put it in your explanation for next, because there are some words that I'm losing, and hoping that next time the connection will be much clearer. So that question you can actually take home and come back to us on that day.
Yeah, I'll share my screen so that you guys can see exactly what I'm doing.
All right, perfect.
Yeah, because I also along the way I've developed some easiest ways of doing stuff so that I don't have to go to the normal procedures that then break down and keep it my way.
All right. Yeah. Okay. All right. Yes.
So are we okay? Because I have something on my table right now to work on.
Yeah, I understand, Patrick. Thank you very, very much.
Yeah.
I'm looking forward to the next session. I will communicate, and once again, thank you very much. Definitely, we will learn from you on how you did it. Thank you very much.
Okay, thank you.
All right. So I
Okay,
guess
see you guys.
yes.
See you guys next time. I think that's enough for now. I've
All
also
right.
learned a lot from what you guys communicated to the group, and also the session earlier we had with what's her name, Esther. Yeah.
Yeah. Yeah.
Yeah,
Okay.
it was just amazing. Yeah.
All right. Thank you very much.
Okay, thank you guys.
All right. Cheers. So I guess having no any other business, what Eunice will do, Eunice is going to share the notebook, and then I'll save this recording together. I understand the recording for the previous class is still not available. I'll also make this available. And then there is this, the planning.ai event that I was a guest speaker. That recording is also not available to most of you guys. So hopefully by tomorrow, all the recordings will be available together with Eunice's notebook. And then we can immediately pick and move towards building our EcoKazi KE chatbot. All right?
Yeah. I gave credit to the wrong person. It was Eunice, not Esther.
Oh, yes. Yeah, that was Eunice.
I'm sorry.
It's okay. Thank you.
Okay, thank you so much, Eunice.
Thank you too.
Have a great evening, all of you.
You too. All right.
Okay, bye.
Bye. Cheers, guys. Enjoy your evening, and in this era, stay safe. Always stay safe. Cheers. Bye.
Bye. Thank you.
Bye.